Okay, so this is the 3+2 programming example using Mastercam. So basically this is using the 5-axis machine, but you're not doing any simultaneous movements. You're just indexing to whatever B and C orientation you need, and then cutting whatever tool paths are assigned at that point. We're going to be importing a part which is provided on Blackboard and the fixturing. Also, you'll need the HAAS content folder to click and drag in. It's specific for the HAAS UMC 750, which we'll be running. It is very important to use that specific content folder and post processor for this file, because we'll be using something called dynamic work offsets, which is G254 and 255, if my memory serves me right. And that post processor, supports that. So let's get into this now. Let's just take a look at the actual part file, what's going to be machined. So I'm just going to go to open, and there's the part file. Now these are all on Blackboard, but I have them downloaded already, so I'm not going to go to Blackboard for this module. So here's the workpiece. It should be a 3-inch piece of plastic with some geometry in the top we're going to cut. Let's take a look at the overall length here. So we'll go into here, just go to analyze distance from here to the existing top plane. It is 5 5/8. That is fine, but let's change that to 6 inches just to keep it simple and to show you some how to work with a model a little bit, in case you haven't done this already. Model prep, push pull, we'll select this plane and we'll pull it this way. Just type in 0.375 and then hit green check. So now if we right click and go to analyze distance from the bottom to the gnomon, 6 inches. Okay. Also, we could right click, analyze entity properties, click here. Because it's from the gnomon, you could get a -6 inches distance there, but the diameter is 3 inches. So we're good there. I can then go ahead and delete this 2D arc that we don't need. And there is our workpiece. So it is very important to cut your stock at 6 inches in length and use 3-inch stock, because we are going to use machine simulation to help us, help ensure we're not going to hit anything when we start moving the rotary axes. So right now, I'm going to go to levels and make sure the part is on. I'm going to do a new level, and we'll rename this as level 2. Okay. And then I'm just going to hit save, and I'm going to save this as, UMC or, 3+2 example, something like that on the desktop. Okay, now that we have the part created and saved, I'm going to do the actual stock now. So we're going to make the stock actually a little bit taller, and that's because I want to face to 0 here. So even the 30 thou bigger is fine. Just know that whatever you do, again, make sure that you cut your stock at the proper length. I am not super worried about the accuracy necessarily of the length. I guess what I'm trying to say is, it's only when things start tipping that I really want to know that we're not going to hit anything. So, we're only going to go like a 64 or a 16th bigger, and then the 0 is still going to be down whatever distance. For us, it'd be a 16th, to make sure the part at the end is 6 inches long. And again, I'm going to leave this saw cut. I'm not going to face that or make that true. I'm doing this for simulation purposes, okay? Because again, this is just an example. So for right now, I want to create a cylinder, and the cylinder, I make this level active. I'm just going to quickly go to wireframe, and I'll just go to curve on one edge, curve this edge, and then I will go to solids, extrude this shape, and we'll go up, and we're going to mess with our colors a little bit. All right, we'll auto cursor right to the top here, somewhere here. And notice that's 6 inches. So again, we'll go to 6.0625, so a 16th longer. And then we'll hit green check. Okay, and this will be our stock. All right, so I'm going to turn the part off. I will then right click and change the stock color to red. So that way we get a decent, contrast between the two. And now our stock is created, okay? The important thing is that we move them at the same time if we ever do, okay? So let's take a look at the next portion of this, which is going to be bringing in the fixturing. So I'm going to go to File, Merge, and again, I already have this downloaded. So ignore my file mapping here. I'm just going to go into my where I know it is on my portion of this, and it's right there. So it open, and there it is. Okay, and again, that is on Blackboard. So make sure that you download it and then bring it in from there. Okay, so I'll go to dynamic, and I'm just going to go to active level there and make sure that that level is active. And I lied. There's different ways to think this through. You can offset by 1, or you can do active level, which is probably what I'm going to do. So I will just do a new level here. Level 3 is active, and this will be the fixture. So then we go back into merge pattern. I'm going to dynamically move this down. Okay, so I'll just select the top here and bring it down here somewhere. Okay, now I could move this where it needs to be, but I want to explain this. So I'll just say green check and green check out of here. So I will recolor this now while we're talking. That'll work. So this is a very simple model of what's going on at the machine. This is actually a 3-draw chuck, and the reason I drew it as a cylinder is 1, because it's easy to draw. 2, I want to make sure we don't hit this at all. Okay, so when you go into simulation, any hits here will be detected, because the chuck could actually move on the fixture plate, and where the jaw locations were can change. So if I was really pushing it and trying to get close to something, I would actually draw the jaws or import the chuck or make it as 100% realistic. But for our example, we don't want to be anywhere near this, so this is fine. What I want to do now is I want to bring this part down to this arc, which represents the top of the jaws. Okay, so a couple different ways to do that. Let's actually just go to transform dynamic. We'll select, and here's the thing, we got to make sure in levels we turn our stock on. Select everything up here, hit end selection, select the bottom, then bring it down in the Z, okay, to this arc. Now we probably have to go transparent so we could see, and we could snap it to a point that is already in there, okay, or highlight over here. See the point? If we highlight to that point right there and click, this should be the right location. Okay, so hit enter and hit end selection. So let's take a look here. Let's go to front view. That is correct. Okay, again, that point is in there as geometry, just select. The other option to do this, there's multiple ways, but the other option to do this is to measure this distance, analyze distance here, bring the part to the top of the chuck and bring it down that distance. But there's multiple ways to do that, and either way works as long as you get the stock in the right position. Now notice the next thing we need to do is take care of our gnomons. Okay, and we have the option here. I want to make sure that all these are on top view for now, and we could bring everything up to this position, which would work. The long axis of this fixture plate is with the x-axis on the UMC, so it's not a bad idea to keep this real simple and just use an existing gnomon. So we can actually, two ways of thought about this. Okay, we can do a new gnomon for the top, and we can put this gnomon at the bottom, and that's a little bit new because, on the 3-axis machine you don't necessarily have to worry about that. But here, that top or any gnomon can be referenced later on to position this workpiece on the table during simulation. Okay, so let's do it this way. What I want to do is I'll select everything, and I'm going to end up using dynamic translate. Okay, and I'm just going to select any corner and only move the Z-axis so that it's true with the top gnomon right there. Okay, then I'll hit green check, clear colors, and fit. So now that is at, the center of the bottom of the fixture, or what's going to be the center of the table. So now what I want to do is go into planes, and I'm going to do a new plane. Okay, and a couple options here. We can go from geometry, we can do dynamic, which is what I'm going to do, or we can do from a solid face, which we'll use later. So we'll go to dynamic, select the top of this stock. Now the only problem is we went to the stock, which is fine for the X and Y, but we need to go into levels, turn the stock off, okay, and bring this Z down to the actual workpiece because we're facing to 0. Okay, so hit enter. And then everything's good here. This will be part. And we're going to manually force this to G54 right in this area here. And this is going to be set at the WCS, T-plane, and C-plane for right now. Okay, we'll hit green check. Notice we have the part, it's work offset G54, and it's set for all of the plane call-outs, I guess you'd say. The work coordinate system, the construction plane, and the T-plane, the tool plane. So that's good. This thing is positioned correctly. Okay, so I'll put a transition here, and then we can continue getting this ready to run. All right, so let's get a machine toolpath group loaded. What we need to do is go to Machine, Mill, and select the HAAS UMC 750 SS post processor. So we'll select that. Now again, that is a content folder available on Blackboard. So make sure you click and drag that content folder into Mastercam, and then you'll be able to go to your your manage list and add it in there just like I have it. So for right now, let's get into the properties and go to tool settings, and I'm going to go from material. We could use Lumen 2024. That's fine for this. I'm going to have you guys going pretty slow just for safety reasons, only because this is the first 5-axis programming some of you may have done. And then I'm going to make sure I assign tool numbers sequentially, and everything else should be okay. We can go to stock setup, and it's up to you if you want to do stock setup in here or a stock model, but I'm going to end up doing a stock model. So I'm just going to hit green check, and this first toolpath group will be stock model. All right, I'll go to toolpaths. Before I do this, I'll go to levels, and I'll turn everything off but the stock. I'll go to stock model, and this will be initial stock. And I'm going to go to model, click it, and click. I'll just click it 3 times to select everything. End selection. Then we'll hit green check. There are no source operations. We'll hit green check. Okay, and notice it's up in space. Okay, so what happened? Let's go back into toolpaths. Go to parameters. Get rid of stock plane, leave it as top, and hit green check. And now it's in the right position. So if we turn it on or off, it's in the right spot. Okay, so again, that was an issue here in the stock plane. It defaulted to part. We wanted to go to top. Now, if you're using 2021 and older, you do not have this generate toolpath icon. That's a green check. If you that automatically regenerates, all you have to do is hit regenerate after that. So if you're using 2021 and older, you won't have that checkbox. So now let's get into what I'll do is go to levels, and I'll turn the fixture and part on and turn the stock off. And then I'll get back in my toolpath window here and turn the stock model off. All right, so that's what we're looking at. So now I'll do a new toolpath group, okay? And this will be top, or let's name it B0 C0. Okay, we have a few operations to do here. We need to face it, and that's facing to 0. And then we need to engrave top on this using one of our, the 1/8 inch 45-degree mill drill is perfect for this. So let's do a facing operation. So we'll select face. Okay, now it's gonna be looking for geometry. What I'll do is I'll quickly go to levels and turn my stock on. Okay, we can go to the 3D options here and just check this face, then hit green check. And now we get in here, go to tool, and I'm gonna go to select library tool and select just a 1/2 inch end mill. Now the critical thing here is we are gonna put a holder in, okay? And the holder is gonna help us see that we make sure we don't hit anything. So the holder, okay, we have to go through the list here. It is a B4 C or C5, sorry. Let's see what we got here. B4 C5, and it should be a 032. So that's for a, if I remember correctly, that's for a ER32 collet. And this is very close to one we have in the shop. The tool projection, we're gonna go to 1.5. Okay. Now, we might reduce that if possible, but that's a great setup for right now. It all depends on what your stick out is at the machine. If we try to go lower, it's going to give us a warning. That's because of the specifications on the end mill. So for right now, this is fine, but make sure you have the holder set up. Okay, again, it's B4C50032 is the holder we're going to be using. So in the tool settings, let's take a look at some of the speeds and feeds. These are all going to be way too fast for what we're doing. I want to have the feed rate of like 25 inches per minute, and the spindle speed of, let's say, 2000 will probably do it. Okay, and again, this is just plastic, so I'm not really worried about it. I just want to make sure that we're going, nice and easy. And that is not efficient in any way, just to be clear. This is just for, making sure that we don't damage the machine or, because mistakes get made the first time you do things like this. The other thing we're going to turn on is force tool change. Now, it's not super critical for this operation because that information is going to be there because the tool is being called out. But force tool change will put the toolpath or the initial information as far as the rotations or the home positions and all that kind of information in the front of every toolpath group or every operation that uses the same tool. So it helps you when you got to go restart a program. In our case, it's going to send the machine over to the tool change position, which will make sure we are well away from the B and C location on the machine. And we'll call this facing. Okay. We'll go to cut parameters. We can go to zigzag on this. That's fine. We're leaving nothing on the floors. And everything else looks okay. I'm not worried about some of this. This is fine. Depth of cuts, we're going to... we have some options here. We could put depth of cut on. Again, it shouldn't be a problem. The only thing is sometimes this can be, because it's plastic, this is not normal plastic. This is more like a butterboard type material, so it can start to chatter a little bit because it's not really rigid. So we can put depth of cuts on, or we can end up, especially when we get into contour, we can use multi-passes of a lesser value. But being only a 1/16 of an inch for this facing operation, and it's pretty rigid in this, I'm not worried about it. It's when we get to the contour that you can get some chatter. So linking parameters, the depth is 0. The top of stock is a 1/16. That's correct. Everything else is okay. We'll turn the clearance on here and incremental. Everything looks good. Okay. Planes are correct. Coolant is going to be off for this example. And that's it. So then we'll hit green check and we'll see our operation. Okay. Now notice, right, where is the toolpath? Let's take a look here. Let's turn the stock off. See how it's up high? Okay, let's fix that. Go to toolpaths, parameters, and let's go. And that's because I chained the top geometry and the linking parameters. Again, the depth is, in this case, an incremental, comes from where the chain geometry is. That's why this came out to a 1/16. So we'll hit green check and then regenerate, and we're good to go. Okay, so that's that operation. What I'll do is I'll put a transition here. We'll take care of the engraving of top using contour. And then we can continue with starting to rotate the B and C axes. Alright, so let's start engraving top on this workpiece. So one thing you need to be careful of when doing this is chain selection, because there's multiple ways to do this. We'll go to contour, and now it's looking for information on chaining. What I like to do is rotate the part right around here, and I like to go to transparent. Now the thing is, you got to make sure that you're not going to select anything behind it. Okay, so right around there is okay. Something like, because the window is going to be true with the gnomon. Somewhere there. There's no 2D geometry really back there. So if we use the window and select everything, then sketch approximate start point, which is going to be right here on the T. Then hit green check. We should be in good shape, okay? We'll review it later to make sure that the geometry is correct. Even if we go here, notice the geometry is all on the top. There is no anything, below it highlighting, so that's good. We'll hit green check. I say that because it'll actually select things below it when you window. It's not like it's on a 2D plane. So for tool, I have my mill drill loaded. That is the same tool that what I would have used for not engraving, for model chamfer on previous operations or previous modules. So you can load yours up. It's there. Create a new one. We're going to run a spindle speed of like 4,000 and a feed rate of 25 inches per minute on the plunge rate as well. We'll turn our force tool change on and rapid retract on, and this will be toolpath comment, engrave top. Holder information is be the same holder as before. Make sure it's the B4C5032. Tool projection 1.5 inches is fine. Just make sure that I'm not going to edit this further, because until you have it set up at the machine, that's when you should go back and tweak this, then run simulation for the final time, and then post the code. Because until you set this up, the projection needs to be as accurate as possible for this type of operation. Okay, so we'll leave it there for now. And again, they might require modifying of the tool depending on what set length mill drill you have. Again, this is probably way longer than what's in the shop. But again, it's got to be as realistic as possible. So cut parameters, we'll go to off for compensation type. Lead in, lead out will also turn off. Linking parameters, we'll go minus 0.015 thou in the depth. Make sure everything's incremental. Clearance will turn on, start to end, 2 inches, everything else is okay. Arc filter is fine, planes will be okay. Coolant, make sure it's off, and then we'll hit green check. All right, so there's our operation. And we can backplot this quickly now. And it looks pretty good. Okay, so that's good. So we have the operations, at least for the rotation, no rotation, B0, C0, completed. Okay, so I'll minimize these, and it's a good time to save. And then what I'm going to do is I'm going to do a new toolpath group. So I'm going to right click, I'm going to go to groups, new toolpath group. Now, I am clicking up here because sometimes you may want to run these separately. If you run them all at the same time, you could post new toolpath groups from here, but you can always select machine group or hold control and select them all later. So I'm going to locate these in this root system here. So I'll right click and I'll go to groups, new toolpath group, and this will be B90 C0. Okay, so these two I'll turn off, and I am going to be doing some copy and pasting. But for right now, I'll put a transition in, let you catch up, get the new toolpath group, get the contour finished, and then we'll continue with taking care of our first rotation plane here. Okay, so we need to get a new plane that will tell the machine to position at the correct angle, B90 C0. So we'll go to planes, and we do not really need a lot of information here. The nice thing about this post is that if you just go to from solid face and select this face, and I always, you can move them, it's not a big deal, that'll be fine. Then hit green check, that's all it needs. So this will be in this orientation, if it lets me select it. B90 C0 point. Okay, everything's fine here. I can leave the work offset to automatic. This is not the work coordinate system, it's just the T plane and C plane. Okay, remember, a change from WCS to C&T is a rotation move to Mastercam. The key here is that now, using dynamic work offsets, which is G254, the machine takes care of a lot of the positioning for us. So this would have a problem using one of the other style posts, or not having dynamic work offsets. You would actually have to position the program would have to come from the machine rotary 0 point, and then that's where your 0 point would be as far as your planes. All your geometry numbers come from that common 0. Using dynamic work offsets, you no longer have to do that. So we just have a plane right here. The only thing this plane is doing is it's telling us that this is a rotation point, and what the z-axis is normal to the top of this plane, and that tells us where the B, or tells the software where the B and C is going. And we'll look at that when we create this toolpath, before we do any others, to make sure that it looks correct. So for right now, what I want to do is go to toolpaths, and we have a facing op, but we're going to use contour for the next one. This contour will be used for the rest of the operations. I'm just going to go to contour, and I'm just going to select this chain here. Okay, so that's fine. I am going to change direction. Okay, it's going that way. Then we can hit green check. So the tool in this case is going to be our 1/2 inch cutter. The speeds and feeds will be 25 and 2000. Again, way slow. And then make sure you have force tool change on and rapid retract. This will pay dividends later. Again, it's not super critical, but I like to have the tool positioned at tool change position on the UMC before any rotation occurs. So this would be the right plane. The holder information should be there if it's not, so we're good there. The cut parameters, we're going to turn wear comp on. Why could you dip the cuts? We will do lead in and lead out. And the multi-passes we'll leave on. We'll go, let's say 1/4 inch. or let's go 5 at 1/4 of an inch, sorry. And then that's good for now. We'll go keep tool down, no finish passes, not worried about that. Linking parameters, the incremental is going to be 0, or the depth, I'm sorry, everything's going to be incremental, all the same. Planes, make sure the difference here, part is 0, 0. The tool plane and C plane are B90 C0. Coolant is off. Let's hit green check, and you'll see our toolpath. Now, let's take a look here. Let's watch this run. Okay, it looks pretty good. All right, that'll work for us. Now this is 3-inch stock. It should cut okay. You might have to, it might shake a little bit. Again, this material is not super stable. It's not like aluminum or something, and even that, hanging out this far with a tool holder, you could run into some issues. It's up to you whether you want to use depth of cuts or not. I would prefer to see maybe a difference in the multi-passes. Instead of taking half the cutter, maybe do 1/8 of an inch, something like that. And then we probably have to increase this to 10. And then just to make this easier to see, we'll turn keep tool down off so we can get rid of some of those blue lines. So there's that. Okay, we can watch this run. So that's 1/8 of an inch a time. Okay, so we'll leave it at that because that's what we're going to copy and paste. I think that'll run better for you. Again, I'm not trying to be efficient at all, but I'm just trying to make sure that this runs pretty smooth and we focus on the rotations for this first time messing around with a 5-axis machine. So we're good there. This is the right plane as far as the toolpath is concerned. And now we can get into the engraving. So what I'll do is I will turn that off. All right. And I'm just going to right click and copy and paste the other contour for the engraving. I'll rename it as engraved right. Okay. And then I need to make some changes. So right now in the geometry, I need to right click and rechain all. And I need to position this around. Go to transparent. And rotate this so I'm not going to select anything else. So something like that will be good. We'll go to window. Select everything. Now notice, see that window square? We can run into issues here. So we'll try to get everything in here. I think it's going to leave the T out. Notice it did. So I'm going to deselect everything. Square this up again. And again, there's other ways to do this, but we'll focus on one method. We'll go here. Select the window. Select a start point. Let's start in the T here and hit green check. We're good there. All the parameters should be okay except for the planes. The planes we need to update to B90 C0. Then hit green check. Okay, let's take a look at this operation and notice it's in the right location. All right, so we just did our first rotation. All right, if we want to, we can select everything and go into back plot, and I'm just going to go to isometric reverse and fit, and we can watch this run. So I'll turn the speed down a little bit and go play, and you'll see it face the top of the workpiece. Then it should engrave top. Okay, then it should change tools and it should rough out that flap. Now, one thing we might have to take care of here is actually extending this a little bit to make sure that we get a flat plane down here. That might not be enough lead in, although it looks close. All right, we could also in verify, it would show us that as well. So it looks good. Then it should change up and engrave right. All right, so that's good. Good time to save. All right, and before I continue, I am going to go into parameters for that, for the contour to rough the flat. I am going to go into lead in, lead out. I'm going to adjust the start and end of contour to extend it, let's say 50%. of the cutter. And regenerate the operation, and you'll see it is longer. Okay, and we should clear that. This tool does it as well. What I'm talking about is making sure that this flat clears here. We'll increase that again. Let's go 100%. And cutting a little bit of air is not a big deal. That will work for us. We just go to top view now. Or right view, sorry. All right, you'll see this is where the flat starts, where the tool comes in. This is where the stock is. That should not be a problem, but again, I will just take care of it now. We'll go to 150. All right, so that'll work. That's fine for this operation. Again, I'd rather clear it up right now because then we can copy and paste later. I'm not looking for total efficiency now. I'm just trying to get the basics covered. So that's where we're at now. Okay, good time to save again. Just the last edit we made. I'll turn this toolpath off. Turn this toolpath off. And before we transition here, I'll put the red cursor down here, right click, and we'll go to a new toolpath group. And this toolpath group name will be B90 C90. All right, let's take care of the planes before we transition. I'll go ahead and go solid here. I'll go to the planes, go planes from solid face. We'll select the back face. I'm not really worried about the rotation here, but we'll hit green check, and this will be B90 C90. And we will set this as T-plane and C-plane for right now. Okay, so now we're ready to assign our next toolpaths, a good place to transition, and we'll continue in a minute. Okay, so to do the rest of these, it's really just a repeat of what we just did with B90 C0. So I'll walk you through this next one, and then I'll complete the other two off camera quickly. And then we'll come back and take a look at the simulator and the other processes we need to do to get this workpiece finished up. So now we have this other plane defined, all right? Notice that the WCS is still part, B90 C90 is what we're looking for. Let's copy and paste both of these, okay? And let's go through the changes that we need to make. So let's take care of the contour first. The first thing we need to do is take care of the geometry. So I'm going to rechain all. And I'm going to take care of this chain right there. Hit green check. And then I'm going to go to parameters. I'm going to go to the planes and change the T and C plane to B90 C90. Okay, right there. We'll hit green check now. And if we regenerate and view the operation, it should look correct. That's good. Let's do the same thing for this other contour. So the geometry we need to change. So we'll right click and rechain all. And then we'll get into here, and we'll go into the, transparent, which is not super critical, but I prefer that. We'll orientate the part right around here. We'll select everything with the window, select a base point, and hit green check. So that is now chained. And we'll go to parameters, and we'll go to the planes and change this to our newest update, the orientation where this occurs. Hit green check. And we'll take a look at it. That's correct. Okay, so now that's all set. We'll go down to transparent, and that is pretty much what we need to do for the rest of the operations. Notice with copy and pasting, the force tool change, all your linking parameters, everything is set, speeds and feeds, everything. We will need to update the comments when we get there, but we'll do that after, or you can do that in process. So I'll leave you there. I'm going to go ahead and finish the last two planes. Remember, take care of your new planes. Okay, just like we did before. New toolpath group, then it's copy and paste and reselect your geometries. So I'll pause right here, transition. I'll finish this up, and then we'll take a look at what's next. All right, so you can see I got all of that programmed. The only thing I'm going to change here is I am going to get into the notes, right plane, engrave right. This one I'll rename, should be back, be the next one. And then keep going here. So after that, it's going to be left. I like to make sure these are organized because the other comments are going to go in the program. So if you do to restart the program, it does help to stay very organized in this area. And this will be front. If I remember correctly, should be the last one. Yes. Okay. So we're all set there. All right. Now, a couple things we need to do. We can take a look at this backplot, so we'll select everything. Then if we go into backplot, you'll see the tool kind of move around the workpiece. So we'll see it take care of the top and engrave, mill out this side, then engrave, and so on and so forth throughout. All right, without any crashes. Okay, now we could look at it and verify. So we go to verify. Now, before I get into that, I did make sure my simulator settings were correct. I have the stock model, initial stock for the stock. The fixtures is the fixture level. I did notice, I didn't show this, but the levels were inaccurate. If you were following along exactly, I did have to assign the fixture to the proper level. For whatever reason, it was not. So we'll get back into Toolpaths, simulator settings. So that's that. Now the simulation in here we'll be messing with that in a minute, but for right now this is fine. Everything's selected. We'll verify this and hit play. All right, and I know it doesn't seem like it's cutting the right, but you'll see the engravings are actually there. It's just going pretty quick. It's only going 15,000 steep. Cutting around. Okay, I got no crashes right now, so that looks good. All right, so what we need to do is take care of the simulation. So on Blackboard, you will have a simulation folder, and that folder needs a specific file map. So for that machine to show up in simulation, okay, in this pull down, it needs to be, okay, if we right click and go to File Explorer, the file map to where to put the folder provided on Blackboard is C, Users, Public Documents. In your case, it's going to be Mastercam 2021, but I'm on 2022, so we'll open that. It's going to be in Machine Simulation, Machine Sim, and there it is right here. Okay, so you're going to want to copy and paste it into this folder, the HAAS UMC folder, and in that folder is this. Don't double folder it. Make sure it's the HAAS UMC 750 folder. It's going to be zipped, so you have to extract it. Extract the folder and make sure that they're all in there. Okay, that's the file mapping. Okay, so PC, C drive, users, public documents, shared Mastercam, whatever year you're using, machine sim, simulation, machine sim, paste it here. Okay, so we're good there. The other thing that's going to happen is it's going to default to automatic, so I'll go back to that. Okay, and we'll hit green check. Now to go to machine simulation, everything's selected. We'll just go in through verify. There's other ways to do it, but we'll go in through verify. Then we'll go to simulation. And in a minute, you'll see the machine load up. So here is the actual machine file. Notice it's up in the air about 2 inches. Okay, how do I know how far that is? That is in simulation. Now, depending on what year you're on, you may or may not have this. If you do not, again, I will work with you. You can send me an email, comment, whatever you need to do, depending on if it's a YouTube person or a student. You can go to distance, axis aligned, here and there. 2 inches in the Z. Okay, so how do we fix that? So we'll get out of this verify window. We'll go back into our simulator settings. We'll go to simulation. I'm going to turn automatic off and go to translation, minus 2.0 in the Z, and I'm going to turn transform into WCS off. Make sure that's off. This is the settings you need. Make sure that the machine selection is the HAAS UMC 750 just put in there. We'll hit green check, and then we'll re-verify this and go into simulation. Hopefully it's in the correct location. Okay, it is. So we're good there. So now this is machine simulation. So the nice thing about this is you can see if you're going to hit something as far as not just the holder, but if you're going to hit portions of the machine itself. And again, that is in your stop conditions. So what we'll do is we'll go turn the performance in the middle. We'll go a little slower and we'll hit play. And you'll see the machine moving. You hit play again and it engraves. Now it rotates. and you'll know if you have an issue in here. You could hit up on the housing of the machine. And you watch it run through its whole setup. Okay, and that's it. So again, this is very useful. That's machine simulation in the verify window. It's also, there's some options here. If you go into the machine, there's a difference between machine simulation in simulator and then machine simulation, the actual verify. We're not getting into this right now. I'm just going into simulate in this. This is just a quick way to do it instead of going through the verify window. You notice it's identical. Okay, so this is what we're doing right now. I'm not going to get into the actual machine simulation until later. Okay, you see the simulator options actually change a little bit if we get into here. I'll just show you this quickly. Just to show you, it is a completely different window. Okay, you'll see the part is not even set up right. But again, I'm just showing you that it is completely different. We are not in this version of machine simulate. We are in the simulator settings. Okay. A little bit different, but this is fine for now for our simple example. This is where we're at, or you go through verify, and you can, these three options are in the verify window. Okay, so let's, now that we verified this, let's go and post the code. Actually, I'll just make sure I select everything here. G1 and post it. Now let's take a look at what actually happens here. So this program's going to be bouncing around a little bit. It's not, you know, again, I told you before, it's not super efficient. You're going to see a lot of rotary movement between things. That's fine. The key here is that without getting into approach and retry parameters and things like that, this is a nice safe way to do this for the first time running a 5-axis machine and programming it yourself. You'll see in the beginning, we go 2 inches above home, Y home, B home, and then X minus 30, which is tool change. You unlock the table. We load tool 1, tool 2 is next in the carousel. And then we go to work offset 54 to C and B, turn the spindle on, okay? Lock the table. Then go to dynamic work offsets, position, tool comp, smoothing settings, take care of facing the workpiece, comp off, cancel tool height, 2 inches above home, home Y, home B, or B0, negative 30 from home in the X tool change, unlock the table, and send the B and Z 0. It's already at 0. That's not a big deal for the B0 operations. You'll see all that again. It's the next op that you're going to see some movement where it goes to B0, X minus 30, all that tool change, force tool change information. And then it gets into, again, rotate to C0 B90, lock the table, dynamic work offsets on, cut around and start milling the workpiece, okay? And then dynamic work offsets off, smoothing off, cancel tool height, up in the Z, home in the Y, put the B to 0, minus 30, okay? Unlock the table, B0, C0, in case it already isn't, MO1 for op stops. Unlock the table again. Again, this is your force tool change. Unlock the table, call up tool 2, C0 B90, and it continues all the way through. Now, all these extra rotary moves are not necessary, okay? But out of making sure, again, we only have one UMC here, I want to make sure we do not damage it. I think that the first time running this machine, this is a pretty safe program. Not only are we using plastic with longer tools than necessary, but we are, again, treating the rotaries all separate. We're not going to leave the B up. We could, again, modify this Toolpath to leave the rotaries where they are, do tool changes, but I think this is a good way to go for the first time running it, to give everybody some confidence and to avoid damaging any of the tooling or the machinery. So that's really it for this one, okay? If you have any questions, please let me know, and thanks for watching.